Let's just cut right to the chase. The difference between sitting on a B and actually securing that A star in biology, it honestly often comes down to how well you understand one specific thing, topic 9.1, the structure of the human gas exchange system. We are skipping the small talk today, because your grade boundaries are literally on the line.
Just take a look at this. Candidate lost all marks despite correct final answer. Ouch, right? That is a direct quote from the Cambridge Principal Examiner report. Imagine doing all that grinding, memorizing the biology, getting the final answer perfectly right, and then walking out with 0 marks just because you failed to show you're working. It's an absolutely painful reality for thousands of students every single year. And you know what? That is exactly what we're going to fix in this explainer.
Section 1. The ultimate exam mistake. Here's the deal. Standard revision, it completely falls apart when you hit the higher levels of A-level biology. Just knowing the facts simply isn't going to cut it anymore. Top-performing candidates, they don't just rely on rote memorization. They show this connected, conceptual understanding that they can seamlessly transfer to totally unfamiliar contexts. Think about it. If you're just reciting textbook facts about alveoli, you're playing a completely different game than the one the examiner is grading. You've got to start thinking exactly like the person holding that red pen.
Section 2. Mastering core biology principles.
Okay, let's unpack a massive trap that so many people fall into: cause and effect confusion. Examiners explicitly report that students are constantly mixing up the biological trigger, the cause, with the physiological response, which is the effect. Like, for example, confusing a change in partial pressure with the actual binding affinity of hemoglobin. You've got to clearly distinguish between these key terms, or honestly, your entire explanation just kind of collapses.
Now, in just a minute, I'm going to show you the exact examiner clue that changes your answer completely. We're talking about the specific terminology they literally scan for to award those top marks. But wait, first, you really need the procedural framework that makes that clue super obvious. Because without this underlying structure, you're going to walk right past those marks without even realizing it.
Section 3. The method mark strategy.
All right, let's dive right into this. This sequence right here is how you guarantee marks, even if your final conclusion somehow goes off the rails. Systematic processing in 9.1 follows a very standardized sequence. Step 1. Deconstruct the question and identify your key elements from the stimulus materials. Step 2. Apply the relevant biological principles. Step 3. Execute your analysis with clear, highly documented working. Step 4. Verify your results and spot any weird anomalies. And finally, Step 5. Present the whole thing in the correct format using precise terminology.
Because, listen to me, if you skip that sequence, this is exactly what you get. A big, fat 0. That's how many marks you get if you just jump straight to the final answer without showing your working, or if you don't clearly state the context. You could be an absolute biological genius, right? But if the examiner cannot see your method right there on the page, they literally cannot give you the marks. It's that simple.
And this brilliantly illustrates exactly what I mean. Check out the flawed B answer over on the left. Notice how it states the effect, sure, but it totally misses the units and it completely lacks context. So yeah, it's technically true, but it's academically weak. Now contrast that with the improved A-star answer on the right. See the difference? It actively extracts data from the table, executes the calculation with crystal clear notation, and nails the correct terminology to link the cause and the effect. That right there, that is the method mark strategy in full swing.
Section 4. Top 3 examiner warnings.
So, avoiding these specific pitfalls is exactly how you lock in those highest grade boundaries. Number 1, like we just talked about, confusing cause and effect. Number 2, forgetting to check units and precise terminology. Seriously, always double-check your graphs. And number 3, giving generic, copy-pasted textbook answers that just aren't